In this episode, we will construct a circuit where a resistor, a capacitor and a diode is in series with the voltage source, whereas two resistances are in parallel with the same voltage source. We will apply a sine wave input and transient analysis to observe the time domain response of the circuit. Next, we will apply AC input voltage whose frequency we will vary over a long range to observe the frequency domain response of the circuit. So, stay tuned, stay focused. Hey guys, welcome back. In this episode, we are going to analyze a circuit where both active and passive components are there. As an active component, we have a diode, and hence primarily this circuit we are referring as Diode Transient and Frequency Response Circuit. By transient and frequency response, we are referring to the time domain analysis and the frequency domain analysis. And here we have resistances and capacitance along with the diode so that we can observe its response in both the domain, that is in the time domain as well as in the frequency domain analysis. For constructing this particular circuit, I'll be using the keyboard shortcuts which you are already familiar with. So without any further delay, let's construct the circuit. So first, I'll double click on the LTSpice icon, and here you can see the LTSpice dashboard is open. I'll go and click on the new schematic icon so that a new schematic dashboard opens. Now, I'll go ahead and first I'll save this file as, I'll give a name, Diode Response Circuit. Why? Because we will see the transient as well as the frequency response of this circuit. I'll save this file. You can see at the left top corner we have the name of the file that we have just given. So we will continue here. First, I will place a resistor. For that, I will hit R from the keyboard. To rotate its direction, I'll click Ctrl+R. So here is the resistance. I'll right click to vanish it. Now I have to place a diode. For that, I'll have to go to components, and from there I'll select diode. I'll click and place. I'll again have to rotate its direction, and I have used the keyboard shortcut Ctrl+R couple of times to rotate this diode. Now I'll click here to place it. I'll right click to vanish it. Now I have to place a capacitor. For that, I'll hit C from the keyboard. Again, I have to rotate its direction. For that, I'll hit Ctrl+R from the keyboard. Now I right click to vanish it. Now I need two more resistors. For that, I'll hit R from the keyboard. I'll place the first resistor here and the second resistor here. I'll right click to vanish it. I'll need two sources. One is a DC source, another is a small signal AC source. For that, I'll hit V. Now this will act as a AC source, and below it I'll place the DC source. I'll right click to vanish it. Now I'll hit fit to screen, and I'll be zooming out a bit so that I can see everything in the screen and I can do the wiring. For wiring, I'll hit W from the keyboard. I'll click here, go up, go right, and click here. I'll click and connect it. I'll click and connect it. I'll click, go right, come down and connect it. I'll connect this to, I'll connect here, come right and click here, go up and connect it. I'll connect this to. I'll right click to vanish it. Now you can see all the placeholders are there. I have to give the real ground. So for that, I'll hit the keyboard, the G key for the ground. I'll place it here. I'll right click to vanish it. For wiring, I'll hit W from the keyboard. I'll connect it. Now the entire circuit is done. All placeholders are there. I'll go ahead and save. Now each placeholders have to be assigned with a value. I'll start with the diode. I'll right click here, go to pick new diode, and I'll pick the 1N914 and I'll click OK. For resistor, I'll right click here. I'll give 56 ohms and I'll click OK. For this, I'll click here and I'll give 560 ohms, and again I'll give the same 560 ohms. Okay, I'll click save. For the capacitor, I'll right click and give the value of 10 microfarad. So 10 microfarad. I'll click save. Now this is a DC source. I'll configure it. I'll give it as 10 volt, and this is a AC source. It will be a sine wave. So I'll right click, go to advanced, and pick sine wave. Here I'll give 0, then I'll give 10 millivolt, and as a frequency I'll give 10 kilohertz. I'll click OK. I'll click save. Now, first we'll do the transient simulation. So for that, I'll go to the SPICE directive. Here I'll type .tran. I'll click OK and I'll place it. Next, I will right click on it to bring on the dialog box. Here I'll give 200 micro. This will be 0 and the next one will be 2 micro. I'll click OK. Then I'll click save. Now I will hit fit to screen so that everything comes under the same screen. Now you can see all the placeholders have received their values and we have given an analysis type, that is a transient analysis, and the voltage also. Now I will do the simulation. For that I'll have to click on the run simulation button. And here the simulation has done. First things first, I'll go to view, then go to SPICE output log, and here by a close looking I cannot see any errors or warnings. So simulation is completed without any error. I'll click the close button to close it. Now first I'll place the input waveform. I'll click, hold and drag it. So this is the input waveform. I'll hit B from the keyboard. One by one I'll analyze the voltage across each component. So this is for R. I'll hit B again. This is for the diode. Then again on the keyboard I'll hit B. This is against the capacitor. I'll hit B. This is for this resistor. I'll hit B. And this is for this resistor. So let me bring on my marker pen here. Here you can see that all these three, that means the source, the resistance and the diode, are in phase. So it is in phase. The way the input waveform is swinging, the voltage waveform is swinging in the resistance and the diode. Now as we go further in the capacitor, right, it do have a shift. And if we look at the amplitude level, so this was 10 millivolt. Now we are getting here somewhat 850 millivolt, around this is 715 millivolt. Okay, maximum, that is peak. Okay, and here in the capacitor, right, we are getting a much more higher voltage, that is 8.4 volt, okay, as a swing. So you can see the waveform is also getting amplified here, okay, as the amplitude, as well as we can see there is a phase shift. So here you can see that this peak has shifted here. This peak was in alignment here. So there is a phase shift in the capacitor. Now the next waveform is from this resistor. So if we go, we can see, so there is again phase shift in between these two. But however, this is in phase with this one, right? Here we see this is in the same phase of this and this. Okay. And here also, here it is in the same phase. Only for the capacitor we see there is a phase shift. Okay, and for everything else it is same. However, the amplitude here is almost it is 8.4 volts, and here it is also the same. Okay, so we have a higher value of the voltage of the signal that we have given 10 millivolts, but almost we are getting 10 volt, which is this amplitude level. So almost it is coming as this amplitude level, and we only see one particular phase shift in the capacitor. Otherwise all of the resistors are almost, and the diode is also in the same phase. Okay, so this was the time domain analysis, that is the transient analysis of this circuit, and we can see how it behaves in terms of amplitude, in terms of phase. Now in the next part of this video with the same circuit, we will see its frequency domain analysis. I'll close this. I'll make this bigger. For the frequency domain analysis, we'll do some small changes here. For this, I'll right click and I'll click none. And here we'll give a AC amplitude of 10 millivolt. I'll click OK. So this DC source remains same, the biasing source. However, this AC source, let me hit aim from the keyboard, select this. However, this AC source we keep static, and instead of transient, we will apply a AC here, that is a .AC analysis. For that, first I'll right click here and I'll go to cancel and edit text directly. I'll comment this one. I'll click OK. Now it's in blue. It's no longer active. How to see? If we go view and go to SPICE netlist, right, you can see now it is preceded by a asterisk. That means it's a comment, like the first line, which is also preceded by a comment, and the commenting character is star, that is asterisk. So now I'll go to the spice directive again and I will give a .ac command. I'll click OK and I'll place it here. I'll right click on the AC to configure it. So here I will select the decade type analysis. Here I will give 10 and the start frequency will be 1 Hz and the stop frequency will be 1 kilohertz. So we have decade, we have a number of points 10, starting frequency is 1 Hz and the stop frequency is 1 kilohertz. So here you can see the .ac statement is getting constructed here and I'll click OK. I'll go to the save button to save it. Now I will hit fit to screen and I'll run the simulation. Now first things first, I'll go ahead and go to view, then spice output log, and visual inspection says there is no error or warning here. So we are okay to go forward. I'll click the close button to close it and here I'll see the various voltage responses across the various components. I start with the R, click, hold and drag. Okay. I'll hit B from the keyboard. For the diode, I will click, hold and drag. Okay. For the capacitor, again I'll click, hold and drag. Now from the keyboard, I'll hit again. For this resistor, I'll hit again. For this resistor. So I'll bring on my marker pen. As this is a frequency domain analysis, we are getting amplitude here and the phase angle here. So the solid line in every case, this one is a solid line and this one is the dotted line. Solid one represents the amplitude, the dotted one represents the phase. You can see that the amplitude, as we vary the frequency, here you can see the scale 1 Hz, this is 10 Hz, this is 100 Hz and this is 1 kilohertz. So this is like in a logarithmic graph. This is going on and we can see the voltage goes up like this in the resistor. The same pattern follows here in the diode. Okay, for the capacitor, it is opposite. The voltage goes down like this. Again, for the next resistor, that is this one, the voltage goes down like this. And for this resistor, this goes up. Okay, so this shows how the amplitude and the phase varies with frequency for this particular circuit across various components. In this entire episode, we have done two types of analysis. One is a time domain analysis, that is with the transient statement earlier, and now we have done the frequency domain response, that is with this one by varying the frequency. Now both we have seen how this circuit behaves in different domains, that means time domain and the frequency domain. And the beauty of this circuit, in this circuit we have used both the active and passive element. The active element is only one, is the diode, and the passive is resistance, capacitance, resistance. So all we have used here as combination of both active and passive devices, and we have seen the time and frequency domain response of the circuit. So we are done here. Thank you very much for watching up to this point, and don't forget to like, share and subscribe. In case you have some dislikes, please put that as words in the comment section down below. And bye for today.